Okay, so kita akan go through soalan yang dah bagi dalam lecture hari tu. So untuk gas, okay, exercise 2. Okay, given the partial pressure for given the ada dua valve sini, 6 liter 0.85 mol, so this one 2.6 decimeter cubic, 1.44 mol Y. So what is the partial pressure of each gas when the valve is open? So bila valve ni dibuka, so gas A akan mix dengan kawasan gas Y. So meaning sekarang ni, instead of volume dia 6 liter, dia akan jadi volumenya 2.6 plus 6 untuk kedua-dua gas. Okay, calculate partial pressure, meaning P for A and P for Y, and total pressure of the vessel. So then P total. So kalau dah dapat dua-dua ni, bolehlah calculate P total. Tambah je PA dengan PY. So given the final answer there. Okay, so now let's calculate. So ada cara yang paling simple. So kita mula yang method yang panjang dulu. So apply Boyle's law. So dalam Boyle's law, kita akan calculate guna P1, V1, P2, V2. So kita calculate initial pressure before valve open. So for A, PA, VA equal to nRT so partial pressure of A, mole of A 0.85 times 0.08206. Okay, this one is gas constant, temperature 300. Okay, divide by volume is 6. So we have 3.48755 atm. Okay, using the same method, calculate partial pressure of gas. Okay, this one, partial pressure for gas. Partial pressure for gas A, then partial pressure for gas Y. So PY, VY equal to NYRT. So PY equal to mole for Y 1.44, R 0.08206, 300 divide by, okay, so 2.6 volume for gas Y. So 13.634 atm. So yang ni ialah partial pressure untuk gas Y before valve open. So kita tahu bila valve open, volume akan increase. So after valve is open, for gas A, P1 V1 equal to P2 V2. So P1 before valve open, so 3.48755. Okay, volume ni pun sama yang before open, 6 liter. So P2 after valve is open. Okay, and V2 mix between volume A and volume Y. So we have P2 is 2.43317 atm. Okay, ini jawapannya. Okay, the same thing. So calculate for gas Y. So P1 V1 equal to P2 V2. So P1 13, okay, yang ni 13 13.634. Okay, volume gas Y 2.6. So we calculate for P2 equal to P2 volume 2, meaning mixing antara dua ni 6 plus 2.6. So we have pressure for gas Y after the valve is open 6.55517 atm. Okay, so dah ada partial pressure untuk kedua-dua gas after valve is open. So to calculate for P total, just tambah dua ni. So P total equal to 2.43317 plus 6.55517. Okay, so we have 6 point. Sorry, 6. Yang ini 4 point. Sorry. This one is 4.122 atm. So after mix baru jadi 6.55517. 4.122. Okay. Yang ni method yang panjang sikit, okay, ataupun kalau nak cari guna method yang simple, so kita akan calculate dengan partial P total dulu. Okay, so nanti kita tengok the second method. So ini method 1. Okay, second method. Okay, this one simple. Okay, kita cari P total dulu. So using PV and RT, P total, V total equal to N total RT. So calculate for P total. So mol total hasil tambah kedua-dua mol tu 1.44 plus 0.85 mol. R gas constant 0.08206, temperature 300. Okay, and V total hasil tambah 6 dengan 2.6. Okay, so we can get P total 6.555 atm. Okay, so yang ini guna ideal gas equation. Okay, another one to calculate partial pressure for each gas. Okay, kita akan guna Dalton's law of partial pressure. So ingat untuk formula Dalton's law of partial pressure. So formula to calculate partial pressure for gas A, mole fraction of A times PT. So mole fraction of A ialah mole of A divided by mole total. So times PT. So mole A 0.85 divided by 1.44 times 0.85. Okay, times P total 6.555. So we get partial pressure 433 atm. Ini simple. Okay, then using the same thing. Okay, so actually kamu dah ada partial pressure A. Kita tahu P total ialah partial pressure A plus partial pressure Y. So to calculate for partial pressure A, kita just minus lah. P total minus partial pressure of A. So 6.555 minus 2.433. 4.122 atm. Okey, ataupun nak menggunakan konsep yang sama ni, so boleh juga guna Dalton's law of partial pressure to calculate partial pressure of Y. Mole fraction Y, PT. So mole fraction Y, mole of Y 1.44 divided by mole total 1.44 times 0.85. Okay, sepatutnya jawapannya samalah, times 6.555 P total 4.122 atm. Okay, any method should be okay. Okay, now exercise 3. Okay, sama juga ni kita ada 2 vessel. So when the valve is open, nitrogen monoxide. Okay, so this thing reaction berlaku. NO react with oxygen, okay, produce N2O4. So this one produce a new substance. Okay, so the first question, calculate mole, initial mole, NO, NO2. So we have volume, we have pressure, so temperature. So bolehlah calculate mole using PV and RT. Okay, and the second question, what is the pressure of the remaining gas? Okay, so after react, kita akan ada salah satu ni akan jadi limiting reactant. So kita perlu determine which one is limiting, NO or O2. So gas yang remaining tu kita akan calculate the pressure. Okay, and what is the mass of N2O4 form? So N2O4 product, so product form will determine by limiting reactant. So kita akan determine siapa limiting reactant, so yang itulah yang akan produce how many N2O4. So we start with calculation of mole using PV equals to nRT. So to calculate mole for NO, so PV over RT, so we have pressure in millimeter mercury, so convert to ATM, 0.25 volume over gas constant 0.08206 times temperature given 350 K. So 5.8411 exponent negative 3 mole of NO. Okay, so the same step to calculate mole for oxygen. Okay, 800 convert to ATM, 0.15. So 0.08206, 350. So we have mole for oxygen, 5.498 exponent negative 3 mole oxygen. Okay, then question B, determine remaining partial pressure. Okay, sebelum kita determine siapa yang extra, so kita perlu determine which one is limiting reactant. So the first step, determine limiting reactant. Okay, from equation, 2 mole of NO we react with 1 mole of oxygen. So tadi kita dah ada initial mole untuk kedua-dua ni. So if we use all mole for NO, which is 5.8411 exponent negative 3. So meaning kita perlukan berapa mole of O2. So ini kamu just cross multiply. Okay, so this one cross multiply. So kita akan dapat sini 2.92055 exponent negative 3 mole of oxygen. Then kita compare. So this one is mole oxygen. Okay, mole oxygen available, this one 5.498 exponent negative 3. Okay, yang kita baru calculate tadi ialah mole of oxygen available. So mole of oxygen needed 2.92055 exponent negative 3. So yang mana lebih besar? Yang available. So kalau yang available lagi besar, meaning mole oxygen akan berlebihan. So oxygen is excess. Okay, so kalau oksigen excess, so meaning dia akan ada lebihan. So lebihan ni lah yang kita akan calculate the pressure. So mole O2 excess equal to mole O2 available minus mole O2 needed. So 5.498 exponent negative 3 minus 2.92055 exponent negative 3. So we have mole oxygen excess is 2.57745 exponent negative 3. Dan bolehlah kita calculate untuk partial pressure of oxygen. So macam biasa gunalah PV equals to nRT. So P oxygen equal to mole oxygen RT over volume. So 2.57745 exponent negative 3 times gas constant 0.08206 times temperature is 350, okay, divide by volume. So volume is 0.15 plus 0.25. Okay, so we have the answer 0.185 atm. Okay, now for question C. Calculate mass of N2O4. So question C, mass of N2O4 determined by limiting reactant. So we know O2 is excess, so NO is limiting reactant. So NO is limiting reactant. So from equation, relation between NO and N2O4, 2 to 1. So because NO is limiting reactant, meaning we use all the mole for NO, which is 5.8411 exponent negative 3 mole. Okay, so calculate how many mole of N2 we produce. Okay, so same goes here. Kita cross multiply. So this one times this one. Calculate for X. So we have X is 2.92055 exponent negative 3 mole of N2O4. Okay, so bolehlah calculate for mass. So mass N2O4 equal to mole times mR. So 2.92055 exponent negative 3 times 92. So we have mass 0.2687 gram. Okay, this one is exercise for water displacement method, okay, yang apply ideal gas equation and also Dalton's law. So we have here excess amount of HCl added to zinc. So meaning this is reaction between HCl and zinc. So produce gas. So what is the gas produced? So ini produce zinc chloride, ZnCl2 and plus H2. So balance equation we have 2 here. Okay, calculate number of mole gas produced in the fraction. Okay, so mole of gas. Mole of gas, we need ialah excess. So because HCl is excess, so meaning zinc is limiting. So because zinc is limiting reactant, so zinc akan determine how many mole of H2 produce. Okay, daripada equation ni, relationnya ialah 1 to 1. Meaning mole zinc akan sama dengan mole hydrogen. So kita just calculate mole for zinc. Okay, so because mole zinc equal dengan mole hydrogen, so calculate mole hydrogen using mass zinc over AR of zinc. So zinc 2.5 gram divided by 65.4. So we have 0.03822 mole. Okay, then volume of gas collected in the cylinder. So volume just calculate using PV and RT because we have mole. So volume of hydrogen equal to mole hydrogen RT over P. So 0.03822. Okay, gas constant 0.08206. Temperature convert to Kelvin. Okay, and divide by. Okay, so this one kilonewton per meter square. So convert to ATM. So 1 ATM equal to 101.325 kilonewton per meter. So kalau kita ada 100 kilonewton per meter. So berapa ATM sini? So kamu cross multiply, nanti kamu dapatlah pressure-nya ialah 100 divided by 101.325. Okay, so tekanlah calculator. So dapatlah final answer-nya 0.957 liter. Okay, ini simple. Okay, the next example, exercise 2. Okay, so yang ini ada water, dia given vapor pressure of water. So remember kita akan guna Dalton sini. So ada given water vapor collected over water. Okay, how many grams? So meaning we want to calculate for mass of oxygen. Okay, so we have P total equal to P gas plus P H2O. So now P gas is oxygen. So because oxygen produced, so P oxygen equal to P total minus P H2O. So P total given 735.5, P water 23.8. So we have P oxygen 711.7 torr. So convert torr to ATM. 1 ATM equal to 760 torr. So 711.7 torr. Berapa ATM? So ini sama cross multiply. So we have 0.9364 ATM. Then calculate mole to get, before we calculate for mass, PV over RT. So pressure for oxygen times volume given, R gas constant 0.08206, and temperature is 25 plus 273.15. So finally we get mole 0.2086 mole. Okay, then we can calculate for mass of oxygen. So mass of oxygen, mole times molar mass. So 0.2086 times 32. So we have 6.675 gram. Okay, so that's all. Okay, hope you can understand the working example step. Okay, thank you.